Hello dear student, this is Devang Shah from LG Institute of Engineering and Technology under the LG University. So far in our previous session we have discussed about the programmable logic devices where you found that any Boolean functions you can easily implement with the programmable AND gate and fixed array of OR gate, right? As part of the PLDs, we have discussed about the different types of rooms, the variation in the rooms like EEPROM, EEPROM. Based on that, again, one step ahead, we are going to discuss about the programmable logic array. Now, in programmable logic array, what just we need to implement the kind of any Boolean functions. That's what the same kind of Boolean function we already discussed during our session in PLDs. Again here, this is nothing but one step ahead of PLDs, where Rome is permanently, it's a kind of fused with the any Boolean function. Now, same way here, if you want to further program your Boolean functions, you can do this particular programming at both the product and sum level. So it's product and sum level. That means here you have a programmable AND planes as well as the programmable OR planes, right? So in the sense it is a programmable or and OR, both gates are available to implement your Boolean function. So you can see in this programming at both the product and sum level you have total three inputs. Now this three inputs, see, you can categorize here three inputs A, B, C in A bar, B bar and C bar form as well as A, B, C. So total you can have a six different literals, and based on that, see, you can implement your Boolean functions, right? So from that, if you check your Boolean functions like f1 and f2, so based on that you have a PLA with three inputs, four product terms, two outputs and programmable output inversion. So what does it mean here? We have taken a kind of programmable connections. Is you can see this particular plane is a programmable connection based on the terms. Like here we have taken a mean terms as like AB, BC, AC and A bar and B bar, right? So based on that you can see this is a programmable or array is available, and what are the different f1 and f2 equation that you can implement here. So could the PLA implement the function without XOR gates? Yes, because basically all these three gates are used to implement any kind of Boolean function, and these three gates planes are nothing but AND, OR and invert. That means the NOT gate, right? So here you can see this after this programmable AND gate, you can have the, see, you can see this two particular dots, like two particular crosses here. One is defined as a B here and the another one is defined as A. So you can have a kind of this product is A dot B. Same way you have a B dot C, A dot C and A bar dot B bar, right? So this particular fuse intact you can see here, right? Based on you have a fuse blown, that means there is no connection, right? So based on that, further you can see the kind of fixed array of or maybe it's a programmable array of OR, right? So if it is a programmable, it becomes PAL, which is a programmable array logic, right? Right now this is a fixed planes of OR gates available, and after that you have used a kind of XOR, right? So based on that, see, either this particular value you can make it as a 1 or this particular make it as a 0. So what does it mean? If you follow a kind of NOR gate, see here NOR gate, that means you can just get the kind of programming the output inversion. So let's say if there are two inputs Boolean functions, right, both are in a form of the mean terms, and any one, let's say you consider as a max term, and at the end you just make it the inversion of this, it becomes the mean term, right? So you can implement so many different kinds of logic in this programmable AND planes as well as the OR planes, right? So this is what one of the added advantages in a PLA system is. It's a you got a more flexibility in terms of making the logic of Boolean functions, right? So based on that, we just discuss about the features of this PLA. It's nothing but compared to ROMs, PALs or PLAs is the most flexible economical devices, just what I have discussed, having programmable ANDs, programmable ORs and programmable output inversions. That's what we have just seen in the first slide. And what are the different advantages? Like PLA can have large number of inputs and n outputs m, so performing implementation of optimized functions that are impracticable for a ROM because of the large number of input and required. So it is easily programmable because you can incorporate more number of inputs and outputs. So PLA has all its product terms available for connecting all outputs, overcoming the problem of limited number of inputs to each PAL, or any product can be shared by all output functions. Let's sum. So yes, it can incorporate sums, dot product, as well as the inversion products. So some PLAs have output that can be complemented to give F expression in terms of the product of sum. Again, the inverted form is SOP. We have just discussed in the first slide. What are the disadvantages? So often this kind of product terms limits the application of PLA solution to two-level multiple output optimization to reduce the number of product terms required for fitting into the PLA. So we have more optimized section, like if you can see here, the function F1 in terms of ABC, function F2 in terms of ABC, and I want to make this particular Boolean function with the help of K-map. You can see there are three inputs because that's a ABC. Three variables are required. Four products I'm going to implement, and two outputs of programmable inversion is possible. So there are total four products like F1. That's what it is available from this particular group of zeros. In a way, this is a inversion kind of platform where instead of taking one in a K-map, I'm taking the zeros in a K-map. So based on that zeros in a K-map, you'll have F1 is equal to A dash into B dash into C plus A dash into B into C dash plus A into B dash into C dash. So based on that, you can take a kind of inversion of F1. See, you can easily have AB plus AC plus BC plus A bar into B bar into C bar, right? So that's what you're converting here, max into mean. And the F2, this is the another F2 map which is given in terms of ones. You can make it in a group and you can generate it like F2 is equal to AB plus AC plus BC. Now from this two particular Boolean functions of F1 and F2, you can categorize like AB plus AC plus BC, which is available in both the functions common, right? So if it is a common, see, only one kind of logic path or the kind of specific logic gates I'm going to employ for making this common function. So I have just need to take care about rest of the main term is A bar into B bar into C bar. So based on that AB, then AC and BC, you can see this particular truth table, the PLA programmable table. You can see there are three inputs, and these three inputs I'm going to implement in terms of F1 and F2. See, AB into AC and BC all are having 1 1 1. So based on that, I have just required A and B 1 1 for a case number 1. For the product term 2, I required A is 1 and C is 1, and then the third product I required B and C both are 1 1. So based on that, I can implement this as a end programming product, right? Same way, and I can making as a sum for a OR programming. So based on that particular term, see, you can see this particular term where all these NOT gates are available here. This is the programmable AND gate. This is a fixed arrays of OR gate where I can implement AB, AC and BC from using this fuse index system, and additionally one A bar into B bar into C bar. That's what available in a function of F1. And what I'm going to do, I'm going to just do the F1 bar. That means I'm going to apply with this particular inversion gate, and F2 is straight away as it is. So from that, see here within three functions AB, AC and BC are common in both the Boolean functions. So I have taken a single path for this. So by that way you can program it, one thing. Second, you can make the sizes very less and the speed is also high, right? So give the algebraic expression, you can see the complete part of this particular design, and from that you can be able to understand now how you can program a different kind of Boolean function based on this, right? Again, further design of PAL, if you are going to discuss, you can see the sum of fixed number of products which is available, where F1, you can see the kind of total four Boolean functions. If I want to implement using this particular programmable chip or kind of programmable array logic, you can see F1 is available is A bar into B bar plus C bar, where it is nothing but a kind of NOT gate is involved, AND gate is involved, and finally the OR array gate is involved. So here the OR gate is involved. So A bar into B bar plus C bar. So first, if I'm going to look for A bar, so you're going to find this particular terms. You can check this A bar is available here. This is the A bar function. Same way, here you have a b bar, so you can see this is a b bar, so there is one more term is a b bar, right? So this is a bar, this is b bar, and then you have a c bar, so you can see this is a c bar and this is available at the c bar, right? So from that you can be able to write a bar into b bar within a same function, c bar, and then finally you have to add it with this fixed term is a fixed array of this OR gate. Finally you will get the f1, right? Now f2 you can realize like a bar into b into c bar plus ac plus a bar into b bar. From that you can be able to find the common is a bar into b bar, so I'm taking the same function as a bar into b bar, so same I'm going to make it here. A bar is this one, b bar is this one, and based on that, see here you can be able to use the same logic here, or you can be able to use the same design to make this two boolean functions at a one plane, right? So this is a AND gate inputs where you can see all these gates are here available, and you just make it like it's a programmable. So this particular array or this particular matrix is available with the AND gates input, which is a programmable, and this programmable AND gates are available here with the fixed array of this OR gate, and by that way, see the complete boolean function you can be able to generate. So based on this particular system, you can now be able to tell what is f3 and what is f4 based on that, because this particular term is like this one of the term is a left, this is the 1 3 number is completely empty, but 1 and 2 is indicates a bar into b bar and c bar, and finally you are making with the end again this particular f and f bar you can still connected with the line number 8 and line number 9, so you can this particular term. So from f3 and f4, see you can implement again two boolean functions within a same design, within a same chip. So that's what very important terms in the design of PAL. What if the function uses the more than three products, implements the multi-level, right? So what are the different features of PLA? You can see the PAL is the opposite of ROM, having a set of programmable ends and combined with a set of fixed or here programmable means selectable input outputs, right? So programmable, that means you can select the input and output lines, and based on that you can create a bar, maybe b bar, then a, then b, like that way. So what are the advantages of this PLA? You can see the for given internal complexity PAL can support large n and m than the ROM, right? So it is nothing but like a one step ahead of the ROM. So there are certain limitations of ROM, and those certain limitations you can implement, again you can overcome using this PLA or PAL system. N terms allowing implementation of multi-level circuits. Some PALs have outputs that can be complemented, allowing the expression in terms of POS like F and F bar. So what are the disadvantage? Has only a limited number of products like ANDs and ORs. So if function needs more product terms, it cannot be implemented directly at two level logics, right? So based on that, again you can see this particular boolean functions where equation f1 is equal to a into b bar into c bar plus a bar into b into c bar plus a bar into b bar into c plus abc, right? So I'm going to pick this one as a w, and you can implement here w is like this is what the function is, a bar into b bar into c. So that is what the a bar into b bar into c, and the next one is abc, right? This is what one of the table I have taken, and rest of all the portion you can see I'm using the same terminology like ab plus bc plus ac. This is the one term, right? Based on that, f1 must factor since the terms is 3 and factor of last two terms as w, this as a w. So that w I'm going to use as a part of my programmable path. So from this particular mean term, see you can make it the full gate not used. See the next slide, and you can see the design where implementation of w I have already made, and the complement of w I'm going to use for a rest of the position or rest of the boolean functions want to get like f1 and f2, right? So once you implement this particular term as w and w bar, you can see this is a part of the programmable AND arrays or part of the programmable input lines, and based on that you can implement f1 and f2 and more functionality based on that, right? So what I'm trying to say that you have a, let's say, 10 number of boolean functions from f1 to f10, and based on that you can categorize, you can allow to take the common mean terms, you can allow to take the complement of mean terms, and you can use those kind of funda or those kind of programmable technique to make this PAL and PLA, right? So based on that ultimately definitely you are going to reduce the logic gates, and within one chip you can have a more number of implementation of boolean functions, right? So this is what the design of PLA and PAL, right? Thank you, dear students. Thank you very much.